Hi, good morning everyone. In this video, I am going to explain how to find out the unknown resistance by taking one example. Here, this is the circuit diagram where the resistances are connected in series parallel combination and voltage V is applied here across points A and B. Let us find out what is the unknown resistance which is connected between the points C and D, and what is the voltage drop across the points VCD. That is VCD we need to find out. And when the voltage drop across the 500 ohm is 2.5 volt, what they had given, the voltage across this 500 ohm resistance is 2.5 volt. Now let us begin with finding out the I2. So let I2 is equal to, what is the formula? V by R. We know from the Ohm's law that is V is equal to IR. Okay. Now V by R is equal to, what is the V? V value is, we know that is 2.5 ohm. What is R? R is 500 ohm. So we will get 0.005 ampere. Okay. Now we find out VCMD, or we simply call it as VCD. Okay, voltage across CD, or we can call it as VCMD, or with this point I consider as M here. So that what is VCD here? VCD is equal to, once we find out this one, these two resistors will be in series. So that VCD is nothing but that is equal to I2 multiplied by 500 plus 50 ohm. I2, this current is also flowing here also. Once we calculated the voltage across this one and current we calculated across this resistance, we can consider these two resistances are in series. So what is the value? 50 plus 500, that is I2 into 550, it is 500 ohm. So what is I2? I2 we calculated, that is 0.005 ampere into 550, that is total 2.75 volt. Okay, we calculated this one. Now we don't know what is I and what is I1 here. So what we calculate first here is I. Why? Because we calculated this resistances. This resistance will be here, it will connected, and what is total resistance? This is 550 ohm, and voltage across this resistance we got here is 2.75 volt. Okay, now what is I here? I1 we cannot calculate until and unless we find out the I and voltage V. Therefore, I am going to calculate I here. I is equal to voltage V, we don't know this one, V minus 2.75. Voltage across the source and voltage across this unknown resistance. So that will be calculating here, divided by the resistance, that is 550 ohm. So the total answer what we get here, voltage here, what here, voltage that is mentioned here in the problem itself, voltage V is equal to 12 volt, that is source voltage. So 12 minus 2.75 divided by 550 ohm. So it is equal to 0.0168 ampere. Now we calculate I1. I is equal to I minus I2. So that will be equal to 0.0168 minus I2 is 0.005 ampere. So that will be equal to 0.0118 ampere. So now what about the VCD? Voltage across VCD is equal to I1 into R. Voltage across the resistance R we are calculating now. I1 R is equal to, I1 is 0.0118 multiplied by R. So that is, we can calculate here as VCD, we know that is, how much is the VCD? 2.7 into equal to I1 is 0.0118. What is R? R can be calculated from these values, that is 233 ohm. This is the way of calculating the unknown resistance and voltage across the resistance. What we have did first, we calculated I2 based on the voltage drop across the 500 ohm resistor, and we got the answer as I2, and then we calculated VCD by taking I2, and these two series resistances are connected in series, that will be 2.75 volt, and then we calculated the current I, because without I we cannot calculate I1. So I is equal to, we get some answer, and I1 we calculated, based on I1 we calculated R, that is unknown resistance R. This will be calculated by the voltage across this resistance is VCD, this is known, and I1 is known. So what is unknown here? R. So we know the formula, that Ohm's law, V is equal to IR. So VCD is equal to I1 into R. So we will get 233 ohm. Clear? Thank you.